Hello, Warhawks. This is Mr. Tipton. Today we're going to talk about some different angles inside and outside of the circle. Previously, just as a quick review, we talked about like when we have a circle here and maybe we have something that's created in the middle of the circle, like a central angle is created, an angle that's in the middle of the circle. We see that if this were, maybe 40 degrees, then this central angle is also going to be 40 degrees. They're the same as each other. And if we look at a situation where instead of intersecting maybe in the circle, if they intersect like on the circle, let's use that same measurement there of when this was maybe 40 degrees, then the inscribed angle was equal to half of the arc. But now we have a situation where we've got two chords that are intersecting here. Notice how they're not intersecting in the center of the circle. So that's going to change around some things for us here. What's going to happen, let me just delete this real quick, is that when the chords intersect in the circle, but they're not in the middle or the center of the circle, the angles are going to be equal to the average of the two arc angles. Now what that means is that when we add, we'll just say one arc plus the other arc, and divide that by 2, we're going to get our angle that's in the center, one of the angles inside of the circle. So what we want to do here for this question is we want to take, okay, so x is here. Now it doesn't matter if x was there or if x was there because those are going to be congruent. They're vertical angles. So no matter what, each one of those angles will be the same thing. But we see that with x, we have this arc that actually goes with x, and we also have this arc that goes with x, and it's not right in the middle, so it's going to be the average of those two arcs. So what we want to do is add one of the arcs, which is 70, plus the other arc, which is 40, and we divide that by 2. 70 plus 40 is 110. 110 divided by 2 gives me that the central angles, or no, I shouldn't call them central angles, but the angles inside the circle there are going to equal 55. So x would equal 55 degrees. This would also equal 55 degrees, and notice how we could actually find this angle because these are supplementary angles. They're on a straight line, so we would just subtract from 180, and we could get that this angle right here was in fact actually 125 degrees. So you could actually find all 4 angles there. So that's how we do ones where chords intersect inside the circle. Let's look at a different situation here where we could have, these are actually called secant lines. They're lines that go kind of like a chord, but they extend outside of the circle. Or we could have situations where they're tangent lines, where we have lines that just barely touch the circle one time and are actually going to create perpendicular angles with the radius of the circle here. But these are examples of tangent lines. We'll look through how to find these angles. So when a secant or tangent lines intersect, create angles outside of the circle, then it's going to be equal to half of the difference between the two arcs. So we want to take what I like to call the big arc, or the larger arc, subtract from it the little arc, or the smaller arc, and then we're going to divide that by 2. So big arc minus little arc divided by 2. So we see here in this particular case, these two arcs, 140 and 50, actually go with x. So we're going to take the bigger arc, 140, minus the smaller arc, 50, and divide that by 2. And that's going to give us the measurement of our angle that's outside of the circle. So here we see 140 minus 50 is 90. 90 divided by 2 would give us a 45-degree angle outside of the circle. Okay, so that's how it's done. Now we look at another way they like to ask these questions. To say, okay, well, here we see a situation where we have two tangent lines. And so we have this arc right here, which I'm going to go ahead and do in like red, told us that it was a 100-degree arc. And you're like, well, I don't have enough information here. I need the big arc. Well, think about it. These are just barely touching there, making this arc part of the circle, which is 100. But we could actually figure out what the other arc is going to be because if we know what 100 is, the other arc is actually the rest of the circle. We know that circles add up to 360. So if this is 100, then this arc would have had to have been 260 to make the whole circle equal to 360 degrees when it comes to our arc angles. So I actually do know the big arc, 260, minus the little arc, 100, divided by 2, is going to give me my angle measure. So 260 minus 100 is 130. 130 divided by 2, and it would tell me that x is a 65, sorry about the sloppy writing, degree angle right there. So x would be 65. Another way they sometimes like to ask questions in these situations where we have tangent lines is to draw in also the radius of the circle and where they intersect with the tangent line. And radius or radii always intersect with a tangent line at a 90-degree angle. So they're like, okay, we want to find x. Well, we don't have this arc measurement here, so x would actually be equal to that arc measurement. We don't really have it, but what we do have is that this is a tangent line intersecting with the radius, which is always going to make a 90-degree angle. This is another tangent line, remember, a line that just barely touches the circle, intersecting with the radius, so it's also going to be 90 degrees. Making this a four-sided figure, all four-sided figures add up to 180, so we could actually do 90 plus 90, which is 180, plus, I'm sorry, all four-sided figures add up to 360, so we could do 90 plus 90 plus 50 plus x, and that's actually going to equal a four-sided figure, which is always going to add to 360. Think about squares and rectangles. 490-degree angles always make 360. So we add 90 plus 90 is 180, plus 50 is 230 degrees, plus x will equal 360. And then we just take and subtract 230 from both sides, and we get x would have to equal, in this case, 130 degrees. So we get x there is 130, which means this arc would also equal 130. That arc would actually equal 230 because they'd have to add up to 360, and 230 minus 130 is 100, divided by 2 is 50. So everything ends up working out great in the end. I hope you enjoyed this. I'll see you in class tomorrow.